What do I have here? Factors or a product? Factors. How do you know they're factors? Because I got one thing that has been grouped together by brackets multiplying by another thing that has been grouped together by brackets. Now, if I expand that, I get, of course, x squared plus 10x plus 24. Yeah? Easy peasy lemon squeezy. These guys are the factors. If none of these guys were there, and I just gave you that, you would reverse what you did to get there and come up with these factors, right? You would need factors that multiplied to 24 and added to 10, correct? If I wanted to go this way. Agreed? All right. If everybody is on that page, then everybody will have no problem with this. Factors or product? Factors. What is the product? 6x squared minus 4x plus 3x minus 2, which would get me 6x squared minus x minus 2. Agreed? All right. So now this is what we want to learn how to factor. Because as you can see, A, the first number there, is not 1 anymore. In here, that number was 1, wasn't it? Yeah. Now it's not. Everybody cool? Now, you have seen a few of these where there isn't a 1 there. But all of those we were able to GCF, weren't we? Can we GCF here? No. So the first thing we have to be aware of, this is trinomial factoring when A doesn't equal 1. A is just the first coefficient. When the first coefficient doesn't equal 1, and there's no way to factor it out. Okay? Here is what I mean by that. If I gave you this, 12x squared minus 2x minus 4, you would factor out a 2, yes? But you would be left with this 6, so you'd be screwed. Is everybody cool? All right, now, let's talk about this. I'm going to come over here. Now, before I go any further, there are, of which I know, 3 ways to factor this. Okay? One of them was the way I was taught when I was your age. It's ugly. It takes a lot of work, and it requires you to really understand factoring. The first couple of years I taught math, I used that, and kids were like, ah, and I was like, damn, I want to do that. Let's let Hazel finish up. All right. Everybody cool? All right. That's the first way. I will not show you that way because I don't wish for you to go, ah, like my previous students. Everybody cool? The second way, in the early advent of the internet, before it became a useless wasteland of garbage, it was still full of actual information, not cat videos. And I used the internet, and I searched high and low for ways to find factoring of trinomials that have a leading coefficient. And what I found was everybody did it the same way I was taught. And I was like, damn, son, kids don't get this. So I continued to search, like Indiana Jones, through piles and piles of digital relics to find a way. And then I did. I found a way. And that way was so simple. and so elegant. I loved it. I took it to the math prom, and I used it for years. Now, there's a problem with this way, though. Something happens at the end of it that looks like magic. And you all go, and I go, no. Magic. It's cool. And then I show you why it works. The reason that it works will make you go, because there's fractions involved, right? And I know you all feel the same about fractions the way Indiana Jones feels about snakes. So, I only show you those fractions. I'll make you do nothing with them. And then there's the third way, which is the new sexy way of factoring these. I hate it because it makes you guess. And if you do not know what you are doing, you might use this method up to 6 or 7 or 8 times before you found the actual factors. Now, I don't know if you are like me, but I don't like to do something 6 or 7 times in a row before I get the right answer, if there's a way to do it once and get the right answer. Okay? So, what I have found out is this newer sexy way of doing it is the way everybody uses. They all use the really old way that I was taught, or they use this new sexy way. When I get math student teachers who are freshly from university, they use this new stupid way that requires guesswork. Guessing is for people who don't know what they're doing. Are we people who don't know what they're doing? No, we aren't. We are people who know what we are doing. So we will not use stupid guesswork, will we? No. As a matter of fact, often at summer school, other math teachers come up to me and say, "Where did you learn that way of factoring trinomials with a leading coefficient?" And then I tell this story. And they're like, "Cool." You guys are like, "Shut up and do the damn math." And I'm like, "I don't care. I'll do the math when I want, because I'm the boss. I am El Jefe, not you." So, let's do math, shall we?
Let's do it.
What about this question bothers you?
The 6.
The 6 bothers you, correct?
Yes.
If there were no 6 there, what would you do? Pretend there was no 6 there. What would you do to factor this? You would look for what?
Something that adds to 1 and times
That multiplies to -2 and adds to -1. Agreed? Okay. But sadly for us, there is a 6 there. So once that 6 goes there, how much bigger is 6 than the 1 that we would be comfortable with? 6 times bigger, yes? So obviously I cannot look for factors of -2. I must look for factors that are what? 6 times bigger than -2. Which is what? -12. So the first step is I take this number which is A, and I multiply it by this number which is C. And I am seeking factors of -12. Those factors must still add to 1. -1, sorry. What are they? Are they 1 and 12?
No.
No. Are they 2 and 6? No. Are they 3 and 4? Yes. How will 3 and 4 get me to -1?
3 minus 4.
3 minus 4. And this looks very familiar, doesn't it? Looks a lot like the factoring we've already done. And that takes us to this wonderful place. X plus 3 and x minus 4. Now you will notice I've written them far apart. And I've done this for a reason. That reason is this. The only reason we knew it was 3 and 4 was because we multiplied by 6, didn't we? So it isn't really 3 and 4, is it? It is 3 because we multiplied by 6. So we better get rid of that multiply by 6, right?
Oh, you're right.
How do you get rid of multiplying by 6? You would divide by 6. Now, what does that give us?
X plus 1/2.
Fractions. Yikes! Oh no!
I don't like it.
Now, would Mrs. Bad Crumble ever allow you to leave that fraction? No, Mrs. Bad Crumble would mark that wrong, even though it's not wrong. She would mark it wrong. So what should you do with that? Simplify it to x minus 1/2. Yes? And what would Mrs. Bad Crumble make you do with that fraction? You would simplify it to 2/3. Agreed? Now, everybody put down their pencils and watch. Right now, what do we have for factors? And x minus 2/3. Agreed? Okay. Watch and watch only. Ignore all this. We're not talking about that. X plus 1/2. X minus 2/3. If I showed you that, what would you do with it? Don't do it. Just tell me.
X squared.
You'd FOIL it, right? Even though I hate the FOIL, you would say, I would distribute it. Yes? And what would I get there? I would get x squared. I would not get 2x. What would I get there?
X. Negative x.
Negative 2/3 x. Yes? What would I get there?
1/2.
Positive 1/2 x. And what would I get there?
2/6.
Negative 2/6. Yes? Now, what would I need to do with that?
Change the denominator.
You would need to add it because those are like terms, correct?
Yeah.
So what I would need to do is I would need to take negative 2/3 and I would have to add 1/2. Now, Eckham has told me I need a combination. Son of a...
Come on.
Here is where we left off. We need to add these like terms, yes?
Yeah.
What is the common denominator?
6.
6. Excellent, which means this is what?
4.
By 2, and this is multiplied by 3. So I get negative 4 plus 3, yes? Which is negative 1/6, yes?
Yeah.
So I get x squared minus 1/6 x minus 2/6, yes? What about that frightens you?
The 1/6.
The fractions. How do you get rid of fractions? Multiply by what? 6. To get 6x squared minus x minus 2. What?
Hold on.
You are effing kidding me. Shut up your face. 6x squared plus x minus x minus 2.
Well, we were talking about that.
So this gets me this, doesn't it? But we don't like writing it this way. This way bothers because fractions scare us. So observe. We knew when we did the long way that at the end we were going to end up multiplying by 6, right? So here, I need to get rid of these fractions, yeah? I could get rid of them by multiplying this side by what? 2. And multiplying this side by what? 3. Then what would I get here? 2x plus 1. And what would I get here? 3x minus 2. Oh my good gravy. There's the answer. Now, hopefully you saw a handy little shortcut. There's a 2 there. It moved to the front. There's a 3 there. It moved to the front.
Whoa.
If it happens twice in math, how often does it happen?
Every time.
Every time. And now you use the knowledge that you already have to do a really hard question.
Was that the magic part?
The magic part is, I usually just say the 2 moves to the front. And all the kids are like, and then I explain it and they're like, but I felt with the pre-dip class I could probably explain it and everybody might be like, all right. I don't like it, but I'll allow it. Everybody cool?
Can you show us one more example?
Well, dude, there's like 20 examples on the page. We always do them, right? This is not your first rodeo, Ekam.
I forgot.
Okay. So, let us look at number 1, cabbages. What bothers us? The 20. Can I divide all this by 20? No, of course not. So I remember that if there's no 20, I need to multiply to 10. But there is a 20. This is 20 times bigger, so this too must be 20 times bigger. So I multiply to 200, and I add to 33. Is it 1 and 200? No. Is it 2 and 100? No. Is it 4 and 50? No. Is it 5 and 40? No. Is it 8 and 25? Yeah. 25 and 8. How will 25 and 8 make 33? Plussy. B plus 25. But it's not really 25 because we multiplied by what? 20. So we have to get rid of that multiplication by dividing. And then b plus 8. But it's not really 8 because we multiply by 20, so we must divide by 20. Now, would Mrs. Bad Crumble like those fractions? No. What would this be?
5 over 4.
And what would this be?
2 over 5.
5. Where do denominators go? To the front.
Yeah.
4b plus 5 and 5b plus 2. Mr. Myers, did I do it right? Kid, check. 4 times 5, is that 20b squared? 5 times 2, is that 10? If the ends are right, the middle's right. Done. Easy peasy lemon squeezy, yeah?
I feel...
What don't I like in number 2? I don't like that 3. That 3 can kiss my blah. So what do I do to get rid of it? Times 3. So I need to multiply to what? Close. Negative 30. And add to what? Because there's a negative right there. Negative 10 times 3 is negative 30. Add to what? Negative 13. Is it 1 and 30? No. Is it 2 and 15? Yeah. A bunch of you were going to say 10 and 3. But no. Because 2 and 15 is the only way to get to negative 13. How? 2 minus 15. So it is s plus 2, but not really 2. What is it really?
2 over 3.
2 over 3. And s minus 15, but not really 15.
15 over 3.
15 over 3. Can I simplify 2/3?
No.
So where does the negative go? Or where does the denominator go?
To the front.
3s plus 2. Can I simplify 15 over 3? Yeah. What is it? 5. S minus 5. Did I do it right?
S minus 5? would that be 5 over 1? So the
5 over 1.
The
And
1
then,
goes to, okay, yeah.
did I do it right? Did I do it right? Did I do it right?
I think so.
Of course I did. 3s times s is 3s squared. 2 times negative 5 is negative 10. Boom. What are you going to do with 3?
Find something that times 2.
No, you're not, because you're going to do this.
Right.
Like I have told you 1,000 times. What's coming out of there?
3.
3. Now what do I need to do?
Find something that multiplies to 2.
Multiply by...
Wait,
I got a number out front that I can't get rid of.
multiply by 2.
So I need to multiply to 6 and add to what? Negative 7. Is it 1 and 6?
No. Yeah.
Yes. How will 1 and 6 get negative 7?
Negative 6 plus
They are both negative, because negative 1 plus negative 6 is negative 7.
Right.
So I get 3x minus 1. But it's not minus 1. What is it?
Minus 1 over 2.
Minus 1 over 2. And x minus 6. But it's not minus 6.
Minus 6 over 2.
6 over 2. And then I simplify my fractions. 3, 2x minus 1, because that doesn't get simpler. And 6 divided by 2 is? 3. So it's x minus 3. Did I do it right? Did I do it right? Did I do it right?
Yeah.
2 times x is 2x squared. Negative 1 times negative 3 is positive 3. 3 times 2 is 6. 3 times 3 is 9. And I did it right. I have an answer.
Why are we learning factoring? How does it help us? Why are we learning factoring? How does it help us?
Well, unlike other teachers, I will actually tell you.
Well, let's do it.
You cannot do higher level math unless you can simplify and factor. That's the only reason. Factoring is simplifying. There is no real life application for it unless you are going to use math in your real life. Now, some of you always say there, I'm not going to do math in my real life. In which I say, awesome, you can see the future? Hell, give me the lottery tickets for next week so I can be rich and quit this job. You can't see the future. You have no idea what you're going to do when you're 40. So you better have a big old mental toolbox to prepare yourself for every damn thing you might do, right? Yeah. So why would you ever not want to learn something that makes you better than the guy beside you who said, I'm never going to need that?
I don't know.
Exactly. See how I win every argument?
Sure.
Number 4. What don't I like?
8.
The 8. Can I get rid of it? No. So what do I got to do with this 5? Times 8. So now I have to multiply to what? No. Negative 40. And add to what? Negative 18. Is it 1 and 40? Is it 2 and 20? Yeah. How do 2 and 20 get me to negative 18? 2 minus 20. Now, p plus 2. But is it really plus 2? What is it? 2 over 8. Can I simplify that now? Yeah. Sure, what is it?
1 over 4.
1 over 4. And then it's p minus 20. But it's not really 20, it's 20 over 8. Can I simplify that now? What is it really?
5 over 1. No, 5 over 2.
5 over 2. Where does the denominator go? 4p plus 1. Where does the denominator go? 2p minus 5. Did I do it right? Did I do it right? Did I do it right? Yeah. 4 times 2 is 8. 1 times negative 5 is negative 5. Is everybody good?
Yeah.
Excellent. Now, you all are going to do those 4. You're going to continue to work until we get to 170. Go.
So 4 minus 9.
Yeah, but 9 times 4
Equals negative 5. Wait, not 9 times 4
9 times 4
is
doesn't equal 3.
36.
It's 36?
Yeah. Because think about it, right? 6 times 6 is 36. No, you're pulling a 6 out of that, right? So that's not
Oh,
there.
wait. Okay, you're right. Oh, you got?
Yeah, 3h minus.
Oh, it's the same because it doesn't matter what order.
I got 3h plus 2 though. I got 2h minus 4.
Yeah.
4 physics.
Did you do minus 4 minus 9?
Oh, it's not basic. Let me redo this one. I think I messed up.
No, you did it right. What did you get for number 5?
Pardon?
Yeah. 3h plus 2h. 3 plus h plus 3 bracket. We all have different answers. Yeah, 4 and 9. It's 4 minus 9. I think I might have messed up. I think we all. Let me do the next one.
Yeah, I did it wrong.
Yeah?
Yeah. Your answer's right.
Mine?
I think. Hold up. What was the answer again? 2h minus 3. And I got, yeah, this is plus. Yes, this is minus 3, right? Yeah. Your answer's right.
I don't know what he did wrong, but in other words, this is right. Yeah. What about the next one? I got that.
I got
since you took the 2 out, you have to put since you
When I take a 2 out, bro. When I take a 2 out.
up here. 2 times 6.
Oh, you have to take it out?
Yeah. Like remember here, we had the 6, right? And that turned into 6, and then x, whatever, with the fractions, right?
Yeah.
We had the 6 out. It wasn't in the fractions. Or it wasn't in the brackets.
When you pull 4 out of here, right? The 6 is left over, right? It's just, when you pull the 4 out, it's still 6h squared minus 5h minus 6. So do you pull the 6 out after
Because 4 times 6 equals 24. Here, 2 times n equals.
Wait, then I got the 2 in over there. That was from the. Shoot, I don't know.
So here I have 2 times 2 equals. 2 times.
Yeah, I think you need to pull the 2 out, yeah.
No?
I don't think so.
Up here.
I think you pulled it out to simplify or something like that.
Are there answers to check? What? For number what? 6? 1 and 12. 1 plus 12. Because here, for example, here, this is up here, right?
Yeah.
So in order to do this, just tell me if you disagree with anything that I did. Okay. So take this 3 out, and it becomes t, and these.
Why'd you 3 out?
I don't know.
What?
That's what you're supposed to do.
No, you're supposed to just leave it and then multiply the 3 by the 4, right?
Yeah, so
And
make
make
that
that
by 4 is 12.
12, and then
right?
take the 8 out.
And it has to be multiplied by 12 add 8.
Yeah.
Which would be
That'd
12
be-
minus 4. And it's all positive.
It would be,
So
what would I get? 6 and 2.
6 and 2?
Yeah.
6 and 2 is 8. Multiplied by 4 is 6 plus 6.
Yeah.
So what I was going to do is I would do t plus 6 over, what is it, 3?
Yeah.
And t plus 6 and simplify. So this is 1 over 2 over 1.
Yeah.
And this,
That's just the 6.
then it becomes 3 3t plus 6 and then 3.
Oh, no, you put it 1. This would be 1 here and 2 there. This would be t plus 2. But remember, you simplified it from 6 over 3 to 2 over 1.
Oh, 2 over 1.
Right.
That's just yeah. For what? 6? What did you get? You can't have fractions. Outline. Or not multiplying. Remove the bottom.
Are you ready to see the last 4 on page 169? 5, 6, 7, 8.
Yeah.
They're highlighted.
Yeah, you don't.
Well, it's a little hard to see number 7, I think. Yeah, a little bit hard. So let's change that.
Oh, so the 2 goes inside the bracket.
Yeah.
So it would be that. 4 and 4.
No, 2 and
You go, girl.
Remember? It's just 2. 2 over there. How we did it up there.
You can't simplify, right? So 2 times 7 is 14. So it has to multiply to 14 and add to it.
Yeah.
Which would be 1 plus 14.
Yeah.
Right? So you would just leave the 2 in. So you'd have, let's just start with m.
Please ask.
M plus
Please ask now if you need to.
over 2.
Please notice I've put all the steps there.
M plus
Of course, some kids are always like, Mr. Myers, is it all right if I do n plus 6 and 2n plus 1?
Oh, okay.
Is it? Yes, because 5 times 2 is the same as 2 times 5. The only thing you have to be careful about is where these guys are. I can't have 2n plus 6 and n plus 1. I can't have that. Or it won't work when I check it. You need to have the next page done for tomorrow. I'm willing to show you the first few answers.
Okay.
They've all been recorded. They will be available for you to check tonight. Although you don't ever need to check my work because you can always check yours, right? If it doesn't work out when you expand it, then you factored it wrong. And you shouldn't hand it in, should you?